Hi Security Tube. This is part 5 of the Exploit Research Megaprimer, and in this video we will look at another new exploit which we will try out using the Freesshd tool. So this tool has a vulnerability which has been publicly disclosed on ExploitDB, and we will look at how to exploit it from start to scratch. So by the way, this little picture-in-picture is a new experiment I'm just trying with this video. So let me know if this kind of makes it look more interactive, or probably whether it is distracting on the contrary, right? So please leave your feedback behind, and based on that I'll probably decide to once again do this in the next video or to exclude the picture-in-picture. Okay, so let's begin. So in this video we will look at how to exploit a vulnerability in the Freesshd server, and this vulnerability exists in the key exchange algorithm and causes a buffer overflow. Now I have given you the link to the ExploitDB vulnerability disclosure. Have a look at that, and after that what we'll try to do is reproduce this bug, and we would use the exact same technique, which is basically the jump to ESP. So this is also a vanilla plain buffer overflow exploit, but you would notice something different here in that EIP and ESP are basically not located in adjacent 4-byte boundaries, right? There is actually a 4-byte between them which is used for something else, right? So small variation, and now let's look at how to go ahead and exploit this. So here is the description of the vulnerability. Click on the link which I have given in the presentation. So basically there is a buffer overflow in the key exchange algorithm, and if you look at the exploit closely, what you would notice is that there is some kind of a header which is first being sent. Now as I mentioned, right now we are trying to recreate existing disclosed vulnerabilities, so we may take some help based on what we are seeing here. Right, so this is like a header which is prepended to the request, and after that seems like we are actually sending our payload. And if you notice, this is quite a large buffer because you have 19,021, 1055 and the shell code and other things in between. So I think it would be safe to assume that probably around 22,000 probably the byte size of the array which we are trying to overflow, right? Also note that this exploit has been created for Windows XP Service 1, Service 2 and the 2000 Advanced Server. So what this basically means is that there is currently no exploit available for Windows XP SP3, which is what our platform is for all our videos. So this is great because now we can actually have a look at recreating this and creating a new exploit code which will work for XP SP3. And that would be very useful, right? Okay, so you can go ahead and download the vulnerable application from here itself. After downloading, once you install, this is basically how the Freesshd would kind of look like and load. Probably give it a second to load. You should have a little desktop, you should have actually a little icon here which kind of pops up. Probably because I've given very less RAM to the machine, it just takes a little bit of more time. So now as you can see, the SSH server is running. Now let's go back and try and recreate this vulnerability. So we have already installed Freesshd. As mentioned, the link is available in the same page as the exploit where you have the vulnerable software. You can double click it to run it. It just takes a bit to load. You should see its icon appear here as soon as it finishes loading. Now it's up and running. Right, so what we'll do is, let's just open this up in Immunity Debugger so that we can immediately get started with analyzing it. Click on Attach Freesshd Service. Attach to it, and then let's quickly just go ahead and restart the service itself. Hit play. And just in a bit you should actually see the service icon appear back. Right, the icon is there. Now let's go to our backtrack instance and start writing some code. So let's call this freesshd.py. Import socket and sys, create a new TCP connection which will actually send data to the SSH service. This would be the IP address and the port number for SSH is 22. Now let's construct the buffer, and then after that we'll just go ahead and send this buffer to the SSH server. Probably we can wait for a couple of seconds. Let's say we can just import time as well, and this called time.sleep, maybe 3 seconds, and then we close the socket. Right? Now as far as the buffer is concerned, as we saw here, we'll first have to prepend this header, and after that we're going to have our payload. Oops. Just copy this here, and now let's append to this buffer with our A's. Let's keep it large value 24,000, and then let's also add the delimiter /r/n. Right, so this is exactly what has been done here as well. And if you notice, you're also receiving some data from the server before sending it the data. So one of the things we can do here is print sock.receive 1024, and then after that we can send our buffer. Right, perfect. Now let's change the permissions, make it executable, and then execute it with the permission set. Right? Now we've sent the data, and if you notice, this has triggered the crash. EIP is pointing to all 41s, which is capital A, and ESP has also been overwritten with the payload. Perfect. Now let's just restart the server. While it's loading, we'll just do what we always did, which is create the pattern. Now this time the pattern is going to be quite large, 24,000. So I'm very sure it's going to scroll down. It'll probably go up. Wow, this is probably the longest pattern I've ever copied. Some reason this terminal looks hung. Let me just start a duplicate session. Well, everything seems to be up. Probably the low memory which I'm using at times does cause these issues. Just pause the video for a second to sort this out. Okay, so now we have a new connection. Let me just log in. Right, and let me open up the freesshd.py, and we'll replace this line with our newly created pattern which we just copied. right? There's going to be a pretty large pattern. Save it. Hi guys, sorry for all the interruption. Now we are back online and let's run the experiment. So the server is up and running, and now we are going to go ahead and send the exploit code from the client side. And looks like we were able to send it. Let's look at the Windows XP instance, and if you notice, there was an access violation and the stack overflow, buffer overflow has happened. Now let's go and actually figure out what we do all the time, which is figure out the pattern offset first. Now we need to figure this out first for the EIP register. Right, so we have 32, 6A, 42 and 31. So this is located at an offset of 1055. Now let's figure out ESP, which basically contains the pattern J4BJ. So we have J4BJ, and this is present at the offset 1063. So now if you notice, these are not adjacent. Basically there's a difference of 8 bytes between them. So if you actually go back here, this seems to be ESP, which is the top of the stack, and this is what is overwriting the return value which goes into EIP, right? And there is actually a 4-byte boundary between them. So a little unconventional, where basically right now what we have to do is overwrite this return address. We don't really care what comes in here, and then from this point onwards we can have our nope sled and the payload, right? So let's go ahead and quickly write up some code for this. So let's delete this line with the long pattern, it's not required. And here, now the first 1055 bytes is immaterial. Let's have A here, 1055. After that, the next 4 bytes is basically going to overwrite the return address. The next 4 bytes are again immaterial. Let's just keep them as A. And then the next 4 bytes is going to overwrite the top of the stack, and from there on we basically can have anything else. So let's say, let's put back our A, and this is going to be, let's say, 23,000 times. Perfect. So let's go ahead, restart this once again. Let's wait for it to start up. Hope this is not distracting. Unfortunately, I cannot always look at the camera and cannot speak. But this is maybe more interactive enough than just a voice. Do let me know. Your feedback is very important to me. So definitely leave behind comments. Okay, so the process has started. And let me go ahead and send the data out. And now let's go. Awesome, looks like the data went through. Let's check on the application, and as expected, we basically now have an overflow. This is where EIP is getting overwritten with all these, then the 4 bytes of don't care, and then we are overwriting the top of the stack, followed by all the AAs down below. So now you can imagine the next step is to figure out the bad characters. So let's restart the server and do that. Let's get our set of characters as usual. So go back to the program very quickly, open it up, and post the C's. Let's go ahead and add our bad character test. Right? Program is up and running. Let's send this. And let's actually wait. So the crash has happened again, and let's just follow ESP in the data dump. And if you actually notice, after the all C's, which is 43, we should actually have a 0, 0, but we have 2C, and then after that it's pretty much random. Right? We have the AAs, but this is because probably this must be present, in some other function's internal variable, right? So there's kind of nothing we need to care about this here at this point. But what we have seen is that after C we are not getting the 0, 0, which means 0, 0 is a bad character. Let's restart the server once again. And while it is still restarting, let's go ahead and remove the bad character 0x00 from the buffer. Right. Now let's get ready to rerun the program. We'll just wait for it to start. Done. Started. Let's send the data across. And let's just wait to see the crash right now. Right? Perfect. Crash as expected. Let's follow ESP. Now if you notice, after the C's, we basically have 0, 1, 0, 2, 0, 3, the increasing order of the patterns, and the good news is this goes all the way till FF. What that means is only 0x00 or the null byte is the bad character. There are no other bad characters for this program, right? Perfect. So now as expected, the next step is to take help from MSF payload. Right, so let's quickly look at the options we have. Right, so what we need is MSF payload. Just did a reverse I search for that. And I think the bad character all we are interested in is 0x00. So let's go ahead and run this and get the shell code. Perfect. So let's just go ahead, copy it all up, go to this terminal, open up our program, and now let's quickly substitute this with our shell code. Right? And the CCs, which is where the top of the stack gets overwritten, let's substitute that with a nope sled. Probably 20 nopes, and this needs to get substituted with basically a jump to ESP instruction location. Let's find that. Then go to view executable modules, and we already know user 32 has a jump ESP. I'll just quickly find the location. Right, this is our old friend 5393 4270. 5393 427E. Right, 5393 427. Perfect. So now I think we are all set to kind of run this exploit. So let's get ready. Let's restart the program once again. Let's wait for it to start and let the magic begin. I guess this is the most interesting phase when you've kind of created the whole exploit and you're planning to try it out and check whether it's actually going to work or not. Okay, perfect. It's loaded. Let's run the exploit and see what happens. Perfect. The exploit has run and still we don't have a crash. In the most common case, this is very good news. So we're just going to take up this IP address, paste it. Some reason the terminal is stuck. No problem. Let's just open up a new terminal. NC 192.168.1.101.4444. Awesome, and our shell is right there waiting for us. Perfect. Process also seems stable. Everything looks fine. So I guess we've managed to exploit. Sorry for the lot of couple of retakes had to happen because there's some problem. I think I'm kind of running out of memory because I hardly have 2 gigs of RAM. I'm running all these VMware machines anyway. So let's exit this. And what we can do is, process is terminated here. Let's just restart a fresh instance and kind of verify our exploitation. Right, that even outside the debugger there isn't any problem running it. Let's wait for the process to start. It's up. Let's run the exploit. So everything looks okay here. Now let's run netcat. Perfect. And now if you notice, basically we are on the desktop. Just do a quick IP config. I think I'm facing some network connectivity issues once again. Okay, that worked. Right. So here we go. Right, and we are in the machine. And I guess as soon as we exit this connection here, the process exits automatically on the host. Right. So that's all for this video. Hope you enjoyed it. Please download Freesshd and try this out yourself. The software is available in the same web page where we have the exploit code given on exploitdb. Sorry for all the inconvenience. I just probably have to get a new machine for myself. Alright, thank you, have fun. Come back for the next video.